Alright guys, welcome back. We're going to be solving another question from the second chapter of Engineering Mechanics by Meriam, and in this one we need to determine the moment associated with the pair of 400 Newton force applied to the T-shaped structure. So as you can see in here, we have two forces that are equal. They're in the opposite direction and they are non-collinear, and that's going to show that these two forces are going to make a couple. So we talked about the couple in 2D questions in the previous videos, and this is the first video that we're going to solve the couple or finding the couple in three-dimensional. So what we're going to do in here, basically we can pick any points from the line of action of the one of these forces. So we can go either with B and moving toward the line of action of the second force, and where we cross that, that's going to be our R in here. And for finding the couple, basically we are looking for a moment. So the moment is, as we talked about, the cross product of R and F. These are all vectors, and at the end of this we need to find the determinant for these two for the cross product. So I, J, K, and now that we have the R in here, we can figure that our R is basically moving toward the x-axis. And in the question, we have the positive side for x-axis and we are going in the opposite way. And we have 0.25 plus 0.25, which is 0.5 meter. And since we are going in the opposite direction, so we need a negative sign in here. 0.5. Again, no movement along y and z axis. So now that we have this, we have to figure out the force in a vector form. So we're gonna go with the force that is applying at point A, and we can see that we can resolve this force into two components. One, this one, we just show it with a different color. So let's just go with green, and this will be the y component, and we know this angle here is 15 degrees. So the y component, as we can see, is along the y-axis. I can show this right triangle in here, then we can see better. Let's just color code it too. So this was our 400 Newton force, and these are the two forces that are actually the rectangular components of this force. So as we can see, actually this has to be, all right, let me just show this force in here. So this is our 400 Newton force, and this will be the y and z component. So the y component, this angle is 15 degrees. We can see the y would be 400 cosine of 15 degrees, and the z would be 400 sine of 15 degrees. So that's about it. We just have to watch for the signs that we have in here. We can see both z and y components are along the positive axes. So they're both positive, no x. So 400 cosine of 15 degrees for J and 400 sine of 15 degrees for K. And the rest of this is finding this cross product. If we just cover, so moment, first of all, is going to be a vector that has ijk component. So let's just go for finding the x component with the I unit vector. So for doing the cross product, as we talked about, so we're just going to cover this and we're going to multiply these two, which is going to be 0. So nothing for that 0 I. Keep in mind that the j for finding the determinant always has a negative sign. So for that, we're just going to cover our j 0.5. So negative 0.5 times 400 sine of 15 degrees, and the other two components will be 0 because it's 0 times 0. So that's going to be our j, and the last one is k. Same idea, we're going to cover k. So basically negative 0.5 times 400 cosine of 15 degrees k. So our moment here would be So 0.5 times 400 times sine of 15 degrees is going to be 51.76 J, and very similar for the other one, times cosine of 15 degrees, except we have a negative sign in here too. So that's going to be negative 193.19 K, and the unit would be, so the force that we have is in newtons, all the dimensions are meter, so it's going to be Newton meter. And the final answer for this question. Everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.